Just minutes ago, the James Webb Telescope discovered the first ever galaxy.
I think in this century, we'll probably pick up signals from an extraterrestrial civilization.
A galaxy so old, it shouldn't even exist yet.
And about 1/5 or so of them have Earth-sized planets.
This new godlike entity that resides in its universe, born before our entire creation.
We realize that we may have to rewrite all the textbooks about the beginning of the universe.
Is throwing our entire understanding of space and time into chaos, forcing scientists to rethink everything. Now they're scrambling to make sense of data that seems impossible. How can a galaxy be older than the universe itself? Let us explore the alien universe old enough to be the creator of humankind. The discovery that defies the cosmos. The implications are monumental, placing long-held theories under scrutiny. Researchers around the world pore over the data, their minds racing to unravel this cosmic puzzle. Proposals for new theories emerge, each attempting to explain the inexplicable. The crux of this scientific quandary lies with the James Webb Space Telescope. Its unparalleled capabilities have peered further into space than ever before, unearthing findings that confound and intrigue. With each celestial image it captures, the telescope seems to open a Pandora's box of questions that could occupy scientists for decades. The idea of changing what we know about the universe is as exciting as it is challenging. Standing on the edge of what might be a major scientific breakthrough, the discovery of this old galaxy could either deepen our understanding of the universe or show how much we don't yet know. We're uncertain about the future, but one thing is clear. The James Webb Telescope has forever changed how we see the universe. This remarkable find makes us rethink what we know about the universe. If it's true that there's a galaxy older than the universe itself, this might mean the universe is older than we thought, or our methods of measuring age might be wrong. Scientists are busy comparing their data with other tools, trying to confirm or disprove what the James Webb Telescope saw. This search not only tests what we know, but also highlights the ongoing effort to uncover the truth in science. Reviewing all this data takes time and caution. Scientists want to be certain before they declare such a significant shift in our understanding of the universe. They are double-checking their work, considering different explanations, and developing new theories to explain this unusual finding. While this is happening, the scientific community is discussing and debating the implications of this discovery. Some are skeptical, thinking that it is more likely an error. Others are excited, seeing it as an opportunity to learn something new and to advance our knowledge of the universe. This discovery has sparked a lot of interest and will likely lead to many more studies and research projects. The James Webb Space Telescope is hard at work studying the far reaches of space, gathering precious information from distant galaxies. Each finding adds to scientists' knowledge about the universe, providing insights into our origins and the cosmic forces at work. Recently, it identified an old galaxy, a significant event in the quest to understand more about the cosmos. As the telescope sends back more data, astronomers use it to check their theories and improve their models of the universe. They are also searching for other old galaxies and cosmic events that might explain the early universe's conditions. This ongoing effort to learn more is essential for advancing scientific knowledge and expanding our understanding of the universe. One particularly interesting discovery is galaxies so old they appear to have formed before the Big Bang, which is thought to have happened about 13.8 billion years ago. This creates a puzzle for scientists. They must either stick to current theories that say nothing existed before the Big Pop, or rethink the Big Bang theory entirely. Following the release of the first deep field image from the Webb telescope by NASA, researchers have been finding new evidence that challenges what we know. Rohan Naidu, a young astronomer at Harvard, and his team discovered a galaxy called Glass Z13, which seems to have formed just 300 million years after the Big Bang. The GLASS in the name stands for Grism Lens Amplified Survey from Space, a global project to find the universe's oldest galaxies. This project initially used gravitational lensing to find these galaxies, and now uses images from the Webb telescope. The discovery of glass Z13 has sparked a lot of discussion worldwide. How could a well-developed galaxy exist so soon after the universe began? The information from this galaxy challenges our current ideas about galaxy formation and the timeline of the cosmos. This might mean we are missing important information or that our whole understanding of cosmic history needs revising. The universe keeps revealing surprises that challenge what we know and push us to explore even deeper. Glass C113 and Macy's Galaxy. As more discoveries come to light, it's evident that our lack of knowledge about the universe is substantial, perhaps even more than what we currently comprehend. Each new piece of data expands our knowledge and highlights the significant gaps in our understanding of the universe's early moments. This ongoing discovery process is crucial as it drives the scientific community to continually test and revise our theories, striving for a clearer and more accurate understanding of our cosmos. There's no question about it. Glass C113 was present in the cosmos 13.4 billion light-years from Earth. This isn't just any distant galaxy. It's one of the brightest ones observed so early in the universe's history. It's filled with activity, highlighted by vigorous star formation that's too significant to overlook. Glass C113 houses a cluster of young, massive stars known as Population 3 stars, which were among the first to light up the universe. These stars are gigantic, extremely bright, and have short lives. The James Webb Space Telescope, Webb, equipped with a sophisticated spectrometer, plays an essential role in studying such distant celestial objects. This device doesn't merely capture light, it meticulously separates it into a spectrum, allowing detailed analysis. When Webb looked at glass C113, it uncovered surprising information. The galaxy has a very low level of heavy elements, known as low metallicity, which is common in young galaxies. However, there's an unusual aspect to this galaxy. It's highly structured, which is not typical for its young age. This finding poses significant questions. How can such a young galaxy already be so well formed? This unusual situation suggests that there might be flaws in our current understanding of how galaxies mature, indicating that our scientific models might need adjustments. Alternatively, glass C113 could be an outlier, an exceptional case that defies standard patterns of galactic development. The implications of Webb's findings are profound, prompting scientists to reconsider some fundamental aspects of cosmic evolution. The data suggest that there might be undiscovered processes at work in the early universe, influencing galaxy formation and structure. Glass C113 stands out not just for its brightness, but as a challenge to our comprehension of galactic dynamics, shining intensely from the remote reaches of space, demanding a thorough examination and understanding. The discovery of galaxies like glass C13 and Macy's Galaxy has significantly shaken our current understanding of how galaxies form and develop. Due to their structure and composition, these galaxies should be several billion years old, according to established scientific models. However, startling research suggests that they are much younger, forming only about 270 to 300 million years after the Big Bang. This timing suggests they began to take shape before the universe itself had officially begun, according to our existing knowledge of the Big Bang. This situation presents a substantial challenge to astronomers and physicists alike. The fact that these galaxies exhibit characteristics of much younger galaxies, such as high rates of star formation and the presence of lighter metals, while also maintaining a level of structural complexity expected in older galaxies, raises serious questions about our fundamental theories of cosmic evolution. The issue became even more intriguing with the confirmation of Macy's Galaxy, named by astronomer Stephen Felstein in honor of his daughter's birthday. This wasn't just a one-time finding. The existence of another such galaxy reinforces the notion that these aren't mere oddities, but perhaps indicators of a significant gap in our understanding of cosmic history. The scientific procedures used to determine the age and characteristics of these galaxies have been thorough. The data has been cross-verified through multiple tests, all confirming the unexpected maturity of these galaxies. This solid evidence makes it hard for the scientific community to dismiss these findings as errors or anomalies. For now, the astronomical community is carefully examining all aspects of these findings, aware that the implications are profound. Further investigations and more data are needed to fully understand how these galaxies fit into the broader cosmic picture. The ongoing study of Glass C13 and Macy's galaxy promises to potentially reshape our understanding of the cosmos, urging scientists to possibly rewrite parts of the cosmic rulebook. But until then, the path of discovery continues, each step revealing more about the complex and surprising nature of the universe. Around 4.25 million years after the universe began with the Big Bang, the earliest stars started to shine, shedding light across space. These stars grouped together in sparse clusters, forming what might think of as early galaxies. These groups were small and simple, which fits with what scientists expect from the universe at such an early stage. However, the discovery of fully formed galaxies containing hundreds of thousands or even millions of stars from this time doesn't fit with our standard theories of how the universe developed. New discoveries in the early universe force us to rethink our old ideas and theories. Hidden realms of the early universe. Dr. Fleeing and his research team have found not just one or two, but many potential galaxies that seem too developed for their age, according to the universe's timeline. In one detailed interview, Dr. Fleeing explained that their telescope's first deep field image likely includes hundreds of these overly mature galaxies. Despite the excitement these findings generate, confirming them involves a lot of careful examination and time. Shortly thereafter, the Webb Telescope captured a second deep field image, adding more complexity to our understanding of the early universe. This image also showed signs that galaxies and stars formed earlier and were more numerous than what our older scientific theories had predicted. The James Webb Space Telescope has supported the idea that stars existed far sooner and in greater numbers than previously thought. The large area of outer space, or cosmos, has been shaken up by new data from the James Webb Space Telescope. This new data is making scientists question what they have long believed about how the universe started and grew over time. As this telescope looks further into distant parts of space, it is giving us views that hint the universe might be very different from what our current ideas suggest. This shift in understanding is significant because it could change a lot of theories about the universe's origins and its development. With each transmission from the JWST, the certainty of established astronomical theories wanes. Scientists are finding themselves in a precarious position of having to reconsider the very fabric of cosmic knowledge. This includes reevaluating everything from the origins of the universe, as suggested by the Big Bang theory, to the processes governing the formation and evolution of galaxies and stars. The possibility that textbooks on astronomy may soon need substantial revisions looms large. Among the most striking revelations from the JWST is the identification of what appear to be 3 dark stars. These celestial bodies, potentially some of the oldest in the universe, challenge the prevailing theories of stellar evolution and galaxy formation. The existence of these dark stars could signify that significant aspects of what scientists believe about the material composition and life cycle of the cosmos might be fundamentally flawed. This unfolding scenario presents a dual challenge for astronomers. On one hand, there is palpable excitement about these novel discoveries, each offering the chance to revolutionize understandings of the universe. On the other hand, there is the daunting task of rigorously testing and validating these findings to ensure they stand up to scrutiny. This balancing act between the eagerness to embrace new ideas and the necessity to meticulously confirm them encapsulates the current state of astrophysics. The reality that our scientific foundations may be flawed is both exciting and daunting. It's thrilling because there's so much new to discover and learn. However, it's also daunting because it means much of what we've taught and learned about the universe could be incorrect. Every new discovery from the JWST doesn't just add to our knowledge, it also raises new questions and doubts. This ongoing challenge of aligning new findings with old theories keeps astronomers and physicists very busy. They are constantly testing their old theories against new evidence, often having to consider that they may need to start over with some basics. This is a critical period in astronomy and physics, where new discoveries are as likely to disrupt as they are to confirm. The James Webb Space Telescope is a key player in space exploration, acting as both a source of knowledge and a creator of mysteries. As it looks further into space than any before, it helps solve some space puzzles but also brings up new, tougher questions. This ongoing process of finding things out and asking more questions excites the science world, pushing experts to rethink their old ideas. With every image and dataset the JWST sends back to Earth, it seems to expand the boundaries of the unknown, challenging astronomers to stretch their minds beyond the familiar territories of cosmic phenomena. This continuous unveiling of the cosmos reveals that the unknown spaces between stars and galaxies are filled with more enigmas than anticipated. It propels the field of astronomy into a new era where the excitement of unearthing fresh celestial secrets is accompanied by the daunting task of re-evaluating and, in some instances, rewriting the very principles that once defined the universe. Around 15 years ago, scientists introduced the concept of dark stars, a new type of celestial object that operates differently from typical stars. Unlike our sun, which produces energy by combining hydrogen atoms into helium, these hypothetical stars are believed to be powered by dark matter. This dark matter constitutes about 27% of the universe's mass and is invisible, as it neither emits nor absorbs light. Dark stars, if they exist, would mark a significant departure from our understanding of star mechanics. Theoretically, they could have formed around 300 million years after the Big Bang, a period when the universe was very young. Scientists have identified certain unusual radiation signatures that don't match those of any known stars, suggesting these might be from dark stars. However, this is not confirmed, and no one has ever directly observed a dark star. The idea of dark stars is an exciting development in astrophysics because it challenges the traditional view of how stars work. If proven, it could reshape our knowledge of the universe's early stages. These stars are interesting not just for their unique power source, but also because they represent an entirely different model of stellar behavior. Dark stars introduce new possibilities, hinting at stellar giants powered by unknown forces. The role of dark stars. However, despite the potential implications, dark stars remain unproven. The radiation that some scientists point to as proof could in reality be from other, unknown sources. The concept of dark stars invites us to consider broader possibilities in the cosmos, but it also requires rigorous testing and validation. Researchers continue to study these signals, hoping to confirm whether they indeed indicate the presence of dark stars or if they have a less extraordinary explanation. The concept that dark matter manifests solely through its gravitational effects on visible objects might have gained support with the notion of dark stars. Should these colossal stars be real, they would serve as indirect proof of dark matter's existence. Such a discovery could significantly deepen our understanding of dark matter, a component deemed vital to the foundation of the universe. By examining dark stars, scientists might unlock hidden about the universe's structure. Dark stars differ from typical stars, emitting light up to 10,000 times brighter than their contemporaries and significantly larger in size. Their role in the early universe could have been more substantial than previously anticipated. During the era when the universe re-illuminated after a prolonged darkness, these stars likely played a crucial role in the formation of galaxies, illuminating aspects of the universe that had remained elusive. This potential discovery suggests that dark stars could be viewed as the universe's initial luminaries, casting light after an extended dark period. Their influence on galaxy formation could provide answers to lingering questions about galaxies whose existence seemed inexplicable until observed with advanced telescopes like the James Webb Space Telescope. It seems that the contributions of scientists like Fritz Zwicky and Paul Dirac, whose work had been overshadowed over time, are gaining recognition once again. Zwicky and Deer were notable figures in the 20th century scientific community. Zwicky in particular conducted seminal work on dark matter. Although their contributions were not widely discussed for years, they are now appreciated as prescient, potentially holding keys to understanding that puzzle contemporary astronomers. This resurgence of interest exemplifies a common theme in science. Previously overlooked ideas can later become pivotal to significant discoveries, underscoring the importance of considering all ideas, regardless of their age, in the quest to decode the universe's complexities. Among the lesser-known concepts in astronomy is the tired light theory, introduced by Zwicky. Renowned for his extensive research on galaxy clusters, particularly the Coma Galaxy Cluster, Zwicky proposed the existence of what he termed dark matter due to gravitational effects that visible matter alone could not explain. Initially met with skepticism, this concept has since become integral to modern astronomy. Zwicky also put forward the tired light theory, which posits that light loses energy and thus appears redshifted as it travels through space. This theory, proposing that light's energy loss results from interactions with space particles rather than from the stretching of space itself, starkly contrasts with the prevailing theory attributing red shifts to the universe's expansion. Although this theory of tired light offers a straightforward and understandable explanation for red shifts, it hasn't won over the scientific community. It challenges the more exciting idea of a universe that is constantly expanding, suggesting instead that the universe might be more static, and that light simply loses energy over long distances. This less flashy, though potentially enlightening view hasn't captured as much attention or acceptance. This situation highlights the difficulty new ideas face in gaining recognition and acceptance in the scientific world, especially when they propose a simpler, less dramatic view of the universe. Zwicky's tired light theory serves as a case study in the challenges faced by theories that clash with established scientific beliefs. It reminds us that in the realm of science, being simple or straightforward does not always equate to being accepted or celebrated. Instead, the theory continues to be a topic of discussion and debate, underscoring the complex dynamics of scientific acceptance and the sometimes slow pace at which the field embraces new ideas. If the shifting of light to red in the universe really means it's just tired, then almost everything we thought we knew about how old the universe is, and how old the galaxies identified by the James Webb Space Telescope are, might be completely wrong. This would mean our entire understanding of space could be based on incorrect assumptions. The idea pushes us to rethink the entire basis of how we calculate and understand the cosmos, which we've been getting wrong for quite some time. Looking back at past theories, we find that the universe's rules might change over time, making us rethink everything. Paul Dirac's revolutionary theories. One of Paul Dirac's major contributions was the Dürr equation. This important formula helps explain how these tiny parts, called fermions, behave and even predicted the existence of something called antimatter. This was once only a theory, but is now a key part of our understanding of the universe. However, Dürr didn't stop there. He boldly suggested that the so-called constants of nature, these are the basic rules that all of physics is built on, might not actually be fixed at all. Dürr thought these constants could change as the universe ages, which means that things thought were permanent and unchanging might actually shift over time. This theory is quite shocking and challenges the very foundation of what physicists have believed for a long time. It suggests that our methods for understanding the universe might be outdated, similar to trying to use an old map to find your way in a city that has since changed. If Dürr's ideas are right, it could mean that the physics community is in for a big surprise, needing to reevaluate the basic rules that were thought to be absolute. The impact here is significant. Our tools for studying space might not just be slightly off, but could be fundamentally flawed, based on no longer correct assumptions. This could mean that much of what we understand about physics might need a major overhaul, showing that even with all our scientific advancements, our view of the universe might be less accurate than we thought, resting on shaky grounds that need to be updated and corrected. This poses a huge challenge for scientists, pushing them to update their understanding and possibly rethink many of the principles that were once seen as the unshakable truth of how the universe operates. There was an idea that the fundamental forces that hold the universe together might change over time. This theory, suggested by a scientist referred to as D, was initially dismissed as too unconventional during his lifetime. It didn't fit with the mainstream views of astrophysics back then and was set aside as a mere curiosity, not worthy of serious scientific exploration. As time has passed, however, this notion has come back into the spotlight. The standard principles of physics, which have long served as the foundation of our understanding of the cosmos, are now being questioned. New findings in the study of the universe are revealing more inconsistencies than ever before, suggesting that perhaps these forces are not as fixed as once thought. The idea that constants in nature might actually vary is gaining traction once again. This shift in thinking is helping to explain some confusing observations, like those concerning the cosmic microwave background radiation. This is essentially the leftover light from the early universe. The patterns in this radiation don't always align with what our old theories would predict. Similarly, the way distant galaxies appear and behave challenges our previous understanding of how the universe has grown over time. A Canadian scientist named Rajendra Gupta has taken a fresh look at these old theories, integrating them with new data. Gupta has come forward with a radical new estimate that suggests our universe might be much older than previously thought, 26.7 billion years, according to his calculations. Another version of his calculations even suggests the universe could be as much as 40 billion years old. These new estimates dramatically depart from previous figures and suggest that the universe's very early stages might be beyond our capacity to directly observe. Durr thought these constants could change as the universe ages, which means that things thought were permanent and unchanging might actually shift over time. This theory is quite shocking and challenges the very foundation of what physicists have believed for a long time. It suggests that our methods for understanding the universe might be outdated, similar to trying to use an old map to find your way in a city that has since changed. If Durr's ideas are right, it could mean that the physics community is in for a big surprise, needing to reevaluate the basic rules that were thought to be absolute. The impact here is significant. Our tools for studying space might not just be slightly off, but could be fundamentally flawed, based on no longer correct assumptions. This could mean that much of what we understand about physics might need a major overhaul, showing that even with all our scientific advancements, our view of the universe might be less accurate than we thought, resting on shaky grounds that need to be updated and corrected. This poses a huge challenge for scientists, pushing them to update their understanding and possibly rethink many of the principles that were once seen as the unshakable truth of how the universe operates. There was an idea that the fundamental forces that hold the universe together might change over time. This theory, suggested by a scientist referred to as D, was initially dismissed as too unconventional during his lifetime. It didn't fit with the mainstream views of astrophysics back then and was set aside as a mere curiosity, not worthy of serious scientific exploration. As time has passed, however, this notion has come back into the spotlight. The standard principles of physics, which have long served as the foundation of our understanding of the cosmos, are now being questioned. New findings in the study of the universe are revealing more inconsistencies than ever before, suggesting that perhaps these forces are not as fixed as once thought. The idea that constants in nature might actually vary is gaining traction once again. This shift in thinking is helping to explain some confusing observations, like those concerning the cosmic microwave background radiation. This is essentially the leftover light from the early universe. The patterns in this radiation don't always align with what our old theories would predict. Similarly, the way distant galaxies appear and behave challenges our previous understanding of how the universe has grown over time. A Canadian scientist named Rajendra Gupta has taken a fresh look at these old theories, integrating them with new data. Gupta has come forward with a radical new estimate that suggests our universe might be much older than previously thought, 26.7 billion years, according to his calculations. Another version of his calculations even suggests the universe could be as much as 40 billion years old. These new estimates dramatically depart from previous figures and suggest that the universe's very early stages might be beyond our capacity to directly observe. Did this video challenge your view of our scientific capabilities? Are we aiming too high with the God formula? Like, comment, and subscribe for more.